Don mentioned that, I've just recently become interested in working with developing heifers, and that's not technically accurate because one of the first things I started working with about 18 years ago whenever I came to Arkansas was with developing replacement heifers. Actually, this slide set is, I just built it on top of one that I was looking at when I first developed it. Was in 1997. So we have been playing around with replacement heifers for quite a while. Interesting. Okay, never had that happen before. So when we're looking at working with replacement heifers, we're really, our goal should be to optimize production by breeding at 15 months of age so that we can calve them as a 2-year-old. That's getting kind of aggressive in getting these replacement heifers developed. But if we want to have the most lifetime production from these heifers and we want to select for good reproduction, we really need to aim for this goal. Also, we want to calve early in the breeding, early in the calving season, so we want to breed them early in the calving season so that they tend to calve earlier in subsequent seasons. And it's been shown over many years that cattle born earlier in the breeding season will wean heavier because they're older at weaning. To get this, the rule of thumb, these heifers need to weigh about 65% of their mature body weight if they're English breeds, 70% if they're Brahman breeds for the most part of mature body weight. Now this can be different for different breeds. We can have late maturing English, we can have early maturing Brahman. A lot of times our continental crosses are later maturing, and we have had some issues with some of the Charolais cross heifers, especially in the early part of the breeding season to at least when we start evaluating reproductive tract scores, how mature are those tract scores before breeding? And a lot of times those continental, larger framed animals will be later maturing. So heifers tend to begin to cycle when they reach a critical body weight and age. This may depend on early versus late maturity. We've been using a lot of Angus cattle at Hope, at the research station down there. And every year we'll have heifers start cycling before weaning even. So, it's not a drop dead rule as far as that 65% of mature body weight, but that's kind of the rule of thumb that we want to hit. Goal is to have heifers cycle before breeding to increase first service conception. The first cycle on a heifer tends to be less successful than a second cycle. So if we have them cycle the second time after the bull's turned in, then we should have better success. So how big is 65% of mature body weight? This is the body weight of our Southwest Station cow herd in 2011. If we look at the average, 1,140 pound average for all of our cows from 3 to 14 years of age, that's just dead on. That's what the industry wants, 1,100 pound cow. That's what we all talk about. We don't have many cows that average, at least within a year, that average that 1,140 pounds. Of course, our younger cows, 3-year-olds, they're still growing until we reach about 5 years of age. This 5-year group, that's a group of cows that we use some AI sires for the entire cow herd, and there's some really nice cows in there, but they are big. It appears that we tend to get smaller as we get older, and that may just be because the bigger cows have fallen out as far as culling, or just because of selection in previous years. So if we look at 1,140 pounds, our 65% goal would be 740 pounds at breeding for those heifers. That year, our average heifer weaning weight was 460 pounds at October 3rd. We went to AI on May 1st, so that's 208 days to gain 281 pounds. or about 1.33 pounds a day. That's relatively easy to get that level of performance on a heifer even through the winter, especially if we have access to small grains or some non-toxic fescue and those types of things. But we want to have genetic improvement with our herd. And we don't select, most of us don't want to select the average heifer. We want to select something better. So we're only going to replace about 10% of our herd. If we look at 10% of the heifers, they did not weigh, the top 10% of the heifers did not weigh 460 pounds. And the cows that produced the top 10% of our heifers did not weigh 1,140 pounds. Whenever we selected our heifers, about 522 pounds was the average body weight of the heifers we selected. The body weight of the dams of those selected heifers was 1,321 pounds. So if we look at just that dam's body weight to predict the heifer's mature body weight, our 65% goal would be about 858 pounds, which means, even though they're heavier, we have to take them to a lot heavier body weight. Our AI goal on May 1st in that 208 days would be to put on 300 pounds or about 1.6 pounds a day, which is still pretty easily done. It's just going to be a little bit harder to hit that target than 1.33 pounds. But the heifer's mature body weight's not going to be the same as the cow's because half of the genetics comes from that sire. So we can estimate that heifer's own mature body weight by looking at frame score. If we know the age of the heifer, measure the height in inches and calculate frame score by using this equation. And then we can estimate mature body weight using 800 plus the frame score times 75, or we can look at this chart. Here we have the age in months, frame score across the top, and this is the inches. So at 7 months of age, we have a 43.3 inch heifer. She's a frame score 5. And then we can look at mature cow body weight down here. That's about a 1,200 pound cow. This is the heifers we used for one of the years of the study I'm going to talk about in a minute. And for these heifer development studies, we need to have a lot of numbers. So we can't just go by using the 25% of the heifers that we grew. So we pretty well use every heifer that we can come up with that looks like it'd be any good at all. And then also we may have to bring some in from other herds within the system. But within this group, we had 8 that were pretty small frame, 2 to 2.9. We had, the majority of them were between, a 4 to a 5 frame score. But when we estimate the mature body weight, we go from about 1,000 pounds up to almost 1,300 pounds. The weaning weight on these heifers was from 408 pounds up to 560 pounds. Our 65% goal then would be right at 650 pounds up to that 835 pounds. So the gain we need, because those smaller heifers had to go to a lighter body weight, is really not that big a spread for all those heifers when we look at the averages for those frame scores. So we're looking at going from about 240 pounds up to about 280 pounds in gain. When we look at spring calving cows, when we wean them in the fall, what are we looking at? They're developed from late fall through the early spring to breed in May and June. So we've got limited forage availability through the winter, harsh weather, which may limit heifer growth. So we can either decrease our stocking rate of tall fescue or wheat pasture so that we can get better gains and have more forage availability, feed large amounts of supplements and hay to get those cattle going. Fall calving cows, what are we facing? We've got heifers weaned in the spring, developed from late spring through the fall to breed in December and January. We've got some really good conditions early, but later on we'll have low forage quality in the late summer, which may limit and into the early fall unless we have some cool season feed come on that will limit heifer growth. So a lot of times that means we're going to have to feed a lot of supplement and hay to get our body weight goals to go. We've been using feed additives for years to increase both growth rate and feed efficiency. Rumensin, Bovatec, Gain Pro are all commonly used, commonly researched products. They increase growth rate and feed efficiency up by about 20%. Growth rate usually more like 10% on pasture. Feed efficiency, we can't measure it on pasture, but if we're feeding these cattle, we will see that feed efficiency benefit. What happens is we're increasing propionic acid production in the rumen and decreasing acetic acid. So this improves the total energetic efficiency of the rumen. Propionate is absorbed in the rumen. It goes into the it can produce glucose, which is increase the blood sugar, which may help cycling as well. But it also decreases methane production, which is a energy waste to the system. So that being said, that's how we increase our growth rate on pasture, is we're getting a more efficient metabolism of these heifers. That can feed into, both because the heifers are bigger and because we have the metabolic machinery available, that it may also increase the cycling rate. So there's been a lot of research that look at these feed additives and how they've been shown to decrease age at puberty and decrease body weight at puberty. So the heifers will reach puberty at an earlier age, lighter body weight, decreasing some of that pressure from feeding supplements and hay to get that gain where we need it to be. So our research plan, we did this study twice, one time with a fall calving herd and one time with a spring calving herd. But in both cases, we had a control where heifers were fed 2 pounds per day of a corn gluten feed with a non-medicated mineral supplement. We fed the Rumensin treatment, same feed, same mineral supplement, but the mineral also contained 200 milligrams per day of Rumensin per heifer. And Gain Pro, these heifers were fed the same supplement with the same mineral, but this mineral supplied 15 milligrams of abambermycin, or the Gain Pro, per day. So in the first study, the fall weaned or the spring-born heifers, there were 70 heifers that averaged right at 450 pounds. 56 of them came from the research station here, which would be Balancer, Gelbvieh, Angus type animals. 14 of these came from the Southwest research station. These would have a little bit more ear, Angus cross type animals. We split these into 14 different pasture groups, 4 control, 5 Rumensin, and 5 Gain Pro, with 5 heifers per pasture. And we ran it from October 29th, which is slightly, right after weaning, after we got the ball out of these heifers, to the first part of May, when we started the AI program, and it lasted 188 days. So we went on Duramax, non-toxic tall fescue for that whole period, except for about a month where we had snow and ice on the ground and no pasture, so they were fed hay. The second study were spring weaned or fall born heifers. There were 72 of them. They averaged right at 500 pounds, 60 of them from this research station here, and 12 of them from the Southeast research station, which has a fall calving cow herd. And these cattle were Beefmaster and a Beefmaster Angus cross type of animal. We had 12 pasture groups. We ran this from June the 24th to December the 2nd, a slightly shorter period of time than before, but we used Bermuda grass from June through October, and then we used the same non-toxic tall fescue from October through December. So in both cases, we used the best forage we had available for those heifers, and would expect to get good performance out of those heifers in both situations. We AI'd these heifers. We used 2 shots of Ludulase to get them set up for AI, and we bred on actual standing heat, or after we observed them with estrus activity. We did not use cedars or feed MGA because we didn't want the progestins in that to cause heifers to start cycling that wouldn't have already started cycling. We wanted this to be the program that we put in, not the cedars or something to push them into estrus. We also use natural service cleanup bulls 14 days following AI, so we're able to pick up, what bred on first service conception versus what was bred later on. We collected progesterone to determine when the heifer started cycling. We looked at reproductive tract scores. We did a blood test to look at which heifers were bred by AI, and then also we looked at total pregnancy rate by palpation after breeding. So just looking at these heifers, we had about a 470 or 80 pound initial body weight, but in all the cases this ranged from about 360 pounds up to 640 pounds. Frame score in the mid 4s, but this ranged from about 2 up to a little bit over 6. So the mature body weight that was estimated for these heifers was about 1,100 pounds, but the estimated mature body weight went from about 950 up to about 1,300 pounds. Pretty good range in heifer and heifer type with this. So our estimated breeding weight would be in the mid 700 pounds, but once again this ranged from about 600 pounds up to 800 pounds. So on the average, our gain that we needed from these heifers was about 250 pounds. And that's about 1.5 pounds a day for that. When we look at the initial animal performance, our initial body weight in the mid 4s, we got a good bump in breeding body weight when we fed the Rumensin or the Gain Pro. We actually got about 50 pounds over the period of the study from feeding the ionophores. So that part at least was really successful. When we look at the average daily gain, our control, we needed 1.5 pounds a day, and that's what we got out of our controls. So on the average, our heifers gained about 1.5 pounds a day with control, about 1.63 pounds per day, 1.64 pounds per day with the Rumensin and the Gain Pro as well. So we got about a 10% increase in performance with the Rumensin and the Gain Pro both. So because we needed about 1.5 pounds a day in all those cases, and that's what we got with the control treatment, we really didn't see any difference in reproductive performance. Our reproductive tract scores were about 3.5, which indicates those heifers right before breeding, all the reproductive mechanisms were starting to work. If they're a 4 or a 5, they're already cycling and have already cycled before. If they're a 3 or 2 or 1 is very infantile, then they're not going to probably breed within that breeding season. So, 3.4 is probably right on target, 3.5. When we look at AI breeding percentage, we were right about 30% with those heifers, just some numerical differences. But the total breeding percentage was about 80% across both studies. We haven't analyzed all of our lab work yet, but our age of puberty in experiment 1, was about a week later or a week older with the control versus the 2 ionophores we fed. The body weight at puberty was slightly heavier with the control versus our 2 ionophores. I don't know if that's really something that we can hang our hat on and go to the bank with, but it does indicate that some of that previous research I cited is probably pretty accurate. And the percent that were pubertal before AI in experiment 1 was in the mid-50s to 70% with that Rumensin treatment. So, about half of those heifers had started cycling before the breeding season, which is to me one of the good things that we need to do. So in conclusion with this, there was no differences in reproductive performance due to the feed additive treatment, but we got the performance we needed out of the controls to reach those targeted body weights and targeted cycling. So, if we are careful in how we produce our heifers and have some targeted approaches to it, we can be successful. So with those preliminary indications, decreased age and body weight at puberty with Rumensin and GainPro, we may have some advantages to some heifers that were not quite ready, but we weren't able to pick that up with this study. GainPro and Rumensin increased gains by 10%. This may have been enough to boost some of the reproductive success of heifers that were right on the edge or may not have been able to breed. So with that, I appreciate the invitation to talk about this and appreciate your attention to my presentation. I'll answer any questions.